Hello and welcome to Fabric in Bits. My name is Brian Rutherford and I'm the CTO, educator and data engineer here at IO Analytics. And today's short talk is going to be about understanding the architecture of Microsoft Fabric. To start with, a very quick bit of background. I've been doing a lot of training sessions around Microsoft Fabric called Fabric in a Day, Fabric in an Hour, where I've been taking people through this architecture in a lot of detail. And what I thought I'd do is try to break these up into nice, short, manageable sessions that you can dip into and learn Fabric as you go along. So, first thing first, Fabric is platform as a service that consists of a number of different components. And I've tried to combine all these components into what I think is quite a useful diagram because there are lots of different versions of this available to you. But I think this one really kind of gets to the nub of what Fabric actually is. And I'm going to explain to you why that is. The first thing then is that we've got OneLake. OneLake is a data lake that is provided by Microsoft to store structured and unstructured data, and that sits beneath the whole of the Fabric instance or tenant. And what you'll find here is you'll find unstructured data, such as spreadsheets, PDFs, JSONs, anything you want to really store here that's unstructured, you can store within OneLake. And you've also got structured data, which might be tables. In particular, in fact, it is Delta tables. If we come back for a second to the unstructured data, the idea behind this is that you might then use some of the tools within Fabric to analyze that unstructured data, to parse it, to pull out some kind of structure, and then hold that in a structured format. Typically, you might take that data and then transform it and bring it into a Delta table and store that in the Fabric Lakehouse. OneLake sits beneath all of the components, but some components automatically write to OneLake and some you have to choose. For example, both the Lakehouse and the Warehouse within Microsoft Fabric automatically store the data in OneLake. But the Event House, you have to switch that option on. And the reason for that is because the Event House typically might contain many millions and millions of records, and it's already storing that data within the Event House internal storage. If you choose to then go in and switch the OneLake option on, it will mirror that data onto OneLake with the storage cost that might come with that as well. So that's OneLake. Above OneLake, we have our compute engines, and these are the components that are processing the data from the data stores, from our interfaces, and letting us then go and read and write to that OneLake storage. Beneath the Lakehouse, we have Apache Spark. We have Polaris for the warehouse. We have Kusto for your event houses, and you may have other database types within Fabric. For example, there's a version of SQL Server that has its own compute engine. But each of these compute engines then is designed for a particular purpose. So for Spark, for example, it's able to go and handle large files at performance speeds. It also allows you to interface with the Spark Compute Engine through languages like Python, using the notebooks to then go and interface with your data and process it in various ways. The Polaris Compute Engine that sits beneath your warehouse is designed for warehouse performance processing. So that's typically enterprise type reporting where you are needing to go in then and process that data and analyze it for enterprise reporting purposes. Kusto is a super fast processing engine that takes millions of records and lets you ask a question of those records and have the answer come back within seconds. Above these compute engines that we know then are processing your data, we have, I guess, the interfaces to these different database types. So what we'll see in a later discussion or video is that each of these has an Explorer type interface. There's a Lakehouse Explorer, there's a Warehouse Explorer, there's an Event House Explorer, and you have a similar idea for the other database types as well. So the Lakehouse itself then, if you go into the Lakehouse Explorer, you will see a graphical interface that shows you your elements that are structured, your tables, and unstructured, the files that are held within OneLake. And there are certain personas then that might use the Lakehouse. I'll come back to that in a second. You've got your warehouse, which again has got an explorer, which you can then access to go and look at your structured data. You've got Event House, which has its own interface, and you can go into the Event House and you can see information about the performance of the Event House itself, about your real-time data. And the Event House really is where you're going to store your real-time data and process it. If we take each of these one by one, we'll see then that the Lakehouse is being used by particular personas, and these might be your data engineers who want to get access to the performant processing power of Spark to transform and orchestrate that data. You may also have your data scientists who are using the notebooks to go in and analyze that raw data for data analysis purposes. There might be a different persona for the warehouse, and this might be your data analyst who's using the Polaris engine, which is a performant engine for data analysis, and it's bringing back that data at performance speeds to let you analyze it and produce the reports that might be sitting over that warehouse. Your Event House then contains real-time data, and that real-time data comes from some kind of data stream. It's being brought into the Event House, and you can then use the Custo KQL query language to go in and actually analyze that data. And that might be for different purposes. For example, one of the data sets that comes as a data stream to test the Event House and let you play about with it is to do with taxi data. And you can then go and see that real-time data to find out where there might be spikes during the day of hires. You can see then things like the real-time revenue, etc. And then finally, you have other database types. For example, you might have SQL Server, and it has its own compute engine which sits beneath that. Just as a quick overview, I mentioned that the Lakehouse and the Warehouse both automatically store the data in OneLake. I mentioned in passing that the Event House, you have to switch that option on. For some of the other database types, that is a similar idea. For example, the SQL Server instance that you can create within Microsoft Fabric has its own data store, but it also mirrors automatically that data onto OneLake. And the reason for that is because you can then use an option called shortcuts. From your Lakehouse, you can actually access the other database types and pull data from them easily using this shortcut idea. Above all of these data store interfaces and the compute engines and the storage layer itself, you have your ETL tools. And these consist of pipelines. So a pipeline is exactly as it is within Data Factory. It looks much the same as the Data Factory version. It's got where's your source, where's your target. It's got the actual transformations that are available to you. It's actually better than the Data Factory version in the sense that they've made the interface a bit easier to use. So it's not simplified, but it's much slicker. Data flows is the same as Power Query within Power BI. So if you ever use Power Query, then you'll find that data flows are very familiar to you. But what they've done here is quite a clever thing. They've basically taken the Power Query from Power BI, they've cut the umbilical cord and they've said, this is actually a really great node for processing. Within this node, we can specify the source, we can specify the target, and in between we have our low-code, no-code data transformation options that exactly as we have within Power Query. So very powerful, and you can create multiple data flows to then go in and do that low-code, no-code kinds of processing. Notebooks, which you may be familiar with, are, as they sound, a notebook interface within which you might find cells, and in those cells you can enter your code, and that might be Python, and it might be Scala, it might be R, and you can go in then and you can use those notebooks to then work upon your data. Typically, the notebooks go with your lakehouses, and you can then go into your lakehouse and you can orchestrate that data, or you can use your notebooks to then do things like data analysis, etc. The other component that is strictly an ETL tool is the event stream. And the event stream is for real-time data. So it will ask you, where's your real-time data stream? What do you want to have to be your target? Typically, it would be your lakehouse or your event house. And in between, it has a graphical transformation panel with a number of transformations that would be familiar to you if you ever use things like pipelines. So it's things like, what columns do you want to go and choose? What do you want to go and do to this data in terms of aggregation, etc. But there is one characteristic about event streams which makes them different from pipelines, and that is that the event stream allows you to control the data stream as it comes in, to divide it up into divisions, let's say, of 5-minute chunks of data, and to aggregate those 5 minutes. And as you bring that data in, 5 minutes gets aggregated, another 5 minutes, and so on and so on. And that is all written to your event house, for example, where you can then go and analyze it. I've also got here the semantic models, because Fabric is designed to interface closely with Microsoft Power BI. So you'll find then that there's a semantic model element to your lakehouse, that you can create a model that sits over the lakehouse. You can create a semantic model that sits over your warehouse. You can create semantic models that sit over, let's say, the SQL Server database type as well. And there is, within certain parameters, the ability to go and do that within the event house as well. And as such, then you can create a Power BI report that sits over that semantic model. And you can do that through the web interface within Fabric to create a web-based Power BI report, or you can use your Power BI desktop to interface directly with Fabric and use that semantic model. I've got it here in the ETL layer because you can use different import types for your data with semantic model, one of them being import, where it holds the data within the semantic model itself. One element to bear in mind about the semantic model is that by default, when you create a semantic model that sits over, let's say, your lakehouse or your warehouse, it's using an option called Direct Lake, where it's actually interfacing directly with OneLake. So when you go in and you actually refresh that data, then it's going to OneLake and pulling that data out and letting you see it in your Power BI report. And it's, again, designed to be performant. So it's a better version of the refresh option, where you could do an option to refresh your data. But this is lets you refresh the data, but it's supposed to be super fast. Over all of that, those layers, we have our activator layer. And this is basically triggers. So in some of the elements, it's still called triggers. For example, in the pipeline, it's called a trigger. But let's use the generic name activators. And what these are triggers that can be monitoring events within the system. For example, there are activators you can create for OneLake that sit over or are looking at OneLake to see if data has been written to OneLake, and that will then trigger an activator to, let's say, run a data flow or a pipeline. There are activators for Azure, which are monitoring blob storage in Azure, and if data is written to a blob storage, again, that can trigger, let's say, a pipeline or a notebook within Fabric. And there are activators for other components as well, for example, for the event stream. So there's an activator where you might add it to an event stream to say, could you look at this data, and when you find a certain threshold is met, could you then trigger an activator? And that might then go on and send a message to you through Teams, for example, send you an email, or it might trigger one of the other ETL tools such as a data flow or a pipeline. Beneath all of those components, you have workspaces. And workspaces are just folders. So in the Fabric portal, when you go to a workspace, you're just looking in a folder, and in that folder, you can then create and store the components that I've just taken you through. So you might have a lakehouse and a warehouse in workspace 1. You might have an event house and event streams in workspace 2. You might have another kind of database in workspace 3. And over all of those workspaces, you have the ability to then go in and actually manage these. So there's a deployment pipeline component which lets you take the components from workspace 1 and move them into workspace 2. So why would you want to go and do that? Well, let's say workspace 1 is your dev components and you're working on them, and workspace 2 is your production. So you can tell Fabric, okay, I'm going to create a pipeline here. Could components X, Y, and Z from workspace 1 and place them in a workspace 2. Not only that, but there's an actions element which you can specify in the pipeline, which says, and when you do that, could you swap the database connection from the dev data to the production data as well. Beneath workspaces, you have domains. And a domain is just a higher way to go and manage your workspaces. So you might have a HR domain where you may have workspace 1 and workspace 2. You might have a finance domain where you have workspace 3. It's just another way to go and organize your components within the workspaces. I've included in this diagram GitHub because you have the ability within Fabric to go and version all of these components. So your lakehouse and your warehouse, your pipelines, your notebooks, your code, etc. All of that can be automatically versioned. And as you change that and make changes over time, that can all be captured in GitHub. And typically, the interface to GitHub is through DevOps. So you've got DevOps, you can go to DevOps, you create a branch in there, and that's basically using the GitHub technology to then go in and actually version your data, the components within these workspaces. Over all of these, you have Microsoft Purview, which is the security layer for Microsoft, and it sits over the Fabric platform as a service. And it really goes and lets you control access at the domain level, at the workspace level, in the components within that workspace, in the ETL tools that work upon those components, on the activators. And that can be for the components themselves right down to the data itself at a granular level. And you have role-based access control within Purview as well. So there we go. That's a quick overview of the architecture of Microsoft Fabric. Hope you found that interesting. IO Analytics are a Microsoft Solutions partner in data and AI. Please get in touch if you would like to know more.